Hello everyone, welcome to this class. This is Teacher Simon taking you through A-Level Pure Mathematics 3, paper 9709, stroke 32 for Feb March 2024. And this is part 1 for questions 1 to 6. Question 1 is coming from polynomials. Find the quotient and the remainder when this polynomial is divided by x squared plus 5. Okay, so let us do this. We have x power 4. Then minus 3x cubed plus 9x squared minus 12x, and then plus 27. Then we have x squared plus 5 here. All what we have to do is to divide the first with the first, then the rest we multiply. So x power 4 divided by x squared, that one gives us x squared, so I write it up here. Then after we multiply, so this times that, of course it gives you this x power 4. Then now 5 times this one, that is 5 x squared. Then we subtract such that we eliminate this x power 4. Now minus 3 minus, of course there is a 0 here because there is no x cubed. So that means we shall have that minus 3x cubed. Then 9 minus 5. That one gives us a 4 not so. So we shall get plus 4x squared. Then these others. Then I can drop these others here. So minus 12x. Then plus 27. Now again we divide the first with the first. So minus 3x cubed divided by x squared, we shall get minus 3x, not so? Then this times this again gives you this negative 3x cubed. And then 5 times this one here, that will be a negative 15 of x. Then after that, we can again subtract such that we eliminate this one here. Then 4, of course we don't have x squared here, so I'll have 4x squared here. Then minus 12 of x, then minus 15. So that is the same as 15, then minus 12, because the minus makes this one a positive, not so? So 15 minus 12 gives us a 3. So we shall have plus 3x, then bring this one down, so plus 27. Then this one divided by x squared, you'll get a 4. So we put that 4 there. Then this times that, again we get 4x squared, and then 5 times the 4, that one gives us a 20. Then when we subtract, this one disappears, and then 3x minus 0, that is 3x. Then 27 minus 20, that is a 7, so plus the 7. So meaning our quotient is equal to what we are having up here, x squared minus 3x, then plus 4. And then the remainder shall be equal to, when you finish, please you write everything down like this smartly, okay? Question 2 is coming from binomial expansions, but find the coefficient of x squared in the expansion of this. So the first thing I'm going to do is to expand this one here. We have 4 minus x. Remember, we are going to use the binomial expansion. If I have a, then plus b to the power of n, then I have my two terms, a, so I first power it with n, then b, power it with 0, then out of 0 factorial. The power of the b is the one I put in the factorial. Now the next one, we drop this power, will be like differentiating with respect to a. So this is a, I mean n, then a, you reduce the power by 1, but that power a has lost, then it is picked up by b, and then you have 1 factorial, the power of the b is the one that comes here, right? Then plus, again drop this one here. So you have n, then into n minus 1, then a, then n minus 2, and then b to the power of 2, out of 2 factorial, then and the rest. Okay, so we shall have 4 minus x here. It is to the power of a half. I'm now expanding this one. This one is endless, so we just end here at this time here, x squared. So we shall have 4, then we power it with a half, then there is minus x here. Please take it with that sign. Then this is 0, then out of 0 factorial. Then the next one, I will drop this power. You will have a half, then that 4, you'll have this a half, then minus 1. So a half minus 1 is negative a half. Then negative x here, then to the power of 1. Then we divide by 1 factorial. And then the next one, drop this one down. We shall have a half, then now times negative a half. And now we have this 4. So you get negative a half minus 1. 2 times negative 1, you get negative 2. So negative 2, then minus 1, that's a negative 3. So we shall have negative 3 over 2 as now the power of 4. Then we have x here, negative x, then to the power of 2, and then out of 2 factorial. This one continues, but I will just end on x squared. Then we can simplify. 4 power half is of course 2. Then these ones are 1. 0 factorial is 1 because there is one way of arranging an empty set. And you know that when it comes to factorials, we are looking at arrangement of objects in a line. So you remember that in paper 5, right? So that's why 0 factorial is what? 1. There is only one way to arrange an empty set. Okay, then this one here is 1 over 2. Then times this is 1 over 4 power half. So that means you have 1 over 2, then times 1 over 2, which gives us what? A quarter, not so? So we have negative a quarter of x, because there is a negative here. And then when we come to this one here, the square is going to make this one a positive. But again, there is a minus here. Now what are we going to have here? If you want, you can even put everything, this one in the calculator, but you can still solve it. This is a half, then times negative a half, then times, this one will be 1 over 4 power 3 over 2. Now 4 power half, what do you get? You get a 2. Then 2 cubed is 8. So that means here we are having an 8. Okay, then here we are dividing by 2. That is the same thing as saying we multiply by a half. So times a half, not so? Because 2 factorial is 2. Then we shall have, this is 4 times 8, that is 34. Then times 2. That one will give us what? 64. But it's a negative. So we shall have minus 1 out of 64 x squared and the rest, but we only stop there. So meaning that 2x minus 5 then times this square root of 4 minus x. This one is the same as having 2x minus 5 then times everything that we have gotten here. Okay, so I just bring this one and I put it there like that. I think I can extend this one a little bit, so like that. But then we want the coefficient of x squared, so term in x squared is going to be, just get the terms that when multiplied they give us what? X squared. So this one here will multiply with this x here, with the term in x. Then this minus 5 will multiply with this. Any other terms that are multiplied will not end in x what? Squared. So we have 2x here, 2x, then times negative a quarter of x, and then minus 5 has to multiply with negative 1 out of 64 of x squared. So that means, of course, 2 times a quarter, you'll get a half. So we have negative a half, and then plus 5 out of 64, because the negative times a negative is a positive, not so. And then put x squared. So meaning coefficient of x squared is going to be what you get here, not so? So I'll multiply this one by 32, then by 32. So negative 32 plus 5, I think that one will give us negative 27. So that means this whole thing is going to be negative 27 out of 64. And that is our final answer. Please, when you are concluding here, there are some people who just write x squared is equal to this. No, you are forming an equation. We have to write coefficient of x squared, then is equal to that. Is that okay? All right. Then next, they are saying state the values of x for which the expansion in part A is valid. Now, we know that for even in the list of family, it is given that if you have 1 plus x, then to the power of n, then the validity is x here, the modulus of x less than 1, or you have from negative 1 less than x less than 1. So what we are having here for 4 minus x then to the power of a half, we need to create a 1 here. Okay, so how do we do so? This one is going to be pull out a 4, factorize it. So we shall have now a 1 here. That means this x is going to be divided by 4. Okay, because you don't have to change the meaning. When you multiply these two, you come back to the x here. You get it? But then this whole thing is to the power of what? A half. So meaning, of course, this a half will come onto this one, and then you have a 2. Then 1 minus x out of 4, then also to the power of a half. Now, since I have created a 1 here, then whatever is here is what I put in the modulus here. Because you are also seeing here, 1 is created, then whatever is here is what they put in the modulus. Okay, so that means I will have negative x out of 4 in the modulus, and then I will say negative 1, I mean less than 1. And we know that if you have modulus of ax, then less than 1, or maybe it's equal to anything. Okay, pull this one out. It is the same as a, then modulus of x, which is equal to that. You get that? So I'm going to pull out this negative a quarter, but remember, when it comes out of the modulus, it becomes a positive. So we have a quarter, then the modulus of x, okay, then less than 1. Then we can multiply all through by 4. That means we shall have the modulus of x, then is less than 4. Okay, I can leave my answer here, or I can say just like here. Then I can say from negative 4, then to 4, and that is that. Question 3 is coming from complex numbers. It is given that z is equal to minus root 3 plus I, part A. Express z squared in the form r e to the power of I theta, where r is greater than 0 and theta ranges from negative pi to pi. Okay, so z squared is going to be equal to negative root of 3, then plus the I. We also square this one here. So square this one, you will get a 3. Then this times that. That one will give us minus 2 root of 3 of I. And then we square this one here, it will give us a minus 1, because you know that I squared is equal to negative 1. So that means this whole thing is 3 minus 1, that is a 2, then minus 2 root of 3. Okay, so r is known as the modulus. Okay, so remember, it is this one that is given here. By the way, we have an I here. So r is going to be the modulus of this z squared. Now, before you find the argument, because this is modulus, but before you find the argument, first find out the quadrant within which the complex number lies. Okay, so first sketch it, and you see if the complex number lies in the first quadrant, well, that is positive. It will be arctan of y over x. Then if it is here, then we are taking this angle. Okay, remember this is 0, then this one will be pi. But if it lies in here and you come like this one will be greater than the 180, and yet you're not supposed to exceed that. So instead of moving anti-clockwise, then we move clockwise, where angles are what? Negative. So we'll be in this region here. Okay, all right. Now let's go back to the diagram. So let's see the quadrant within which this one lies. Of course, you know that this is the real of the z, and this is the imaginary of the z, or z squared, whatever, for this case. Then where does this one lie? We are having the real part is 2, it is positive, then the imaginary is negative. So positive real axis, then negative real axis. That means this one is in here. Okay, this should be the quadrant within which it lies. Then I can connect these points here. Then when we connect them, so I'll put a 90 here. The real is 2 units. Then this one is 2 root of 3 going down. So it will form this angle here. Now that will be the argument. The argument, we are looking at that deviation from the positive real axis. Okay, the angle the complex number makes with the positive real axis. So when you look at this and this, they form this right angle triangle. So this is our z squared coming like that. Okay, now we are going to get the modulus of this, that is the length. So because this one forms a right angle triangle, then we can use SOHCAHTOA, not so. So I mean the Pythagoras theorem. So we have a 2 here. We shall have 2 squared, then plus minus 2 root of 3 squared. And then 2 squared is of course 4. Then plus this one here is 4 times 3, 12. So I'll have a 12 here. Now 12 plus 4. That one gives us 16. Then root of 16 will be a 4. So this whole thing gives us a 4. Then from here, because an angle is involved and this is a right angle triangle, then we can use SOHCAHTOA. So tan of theta then shall be equal to the opposite over the adjacent. I can even put on that negative there. And then our theta is going to be equal to the arctan of this minus root 3. Of course, it will give us minus pi over 3 minus 60 degrees. So this simply implies that z squared then shall be equal to 4, then e to the power of negative pi over 3. Then we put the I, and that is that. Part B, the complex number omega is such that z squared omega is real, and this one here is equal to 12. Find the 2 possible values of omega, giving you answers in the form this one here, where r is greater than 0 and alpha is also lying in the range negative pi to pi. Now there is something I want you to know. If I have, let's say, z1, okay, which is equal to r1, then I mean e to the power of I theta 1, and then we also have z2 that is equal to r2 e to the power of I, then theta 2, okay, and then I get z1 times z2, because here I'm seeing a multiplication, okay. Then we shall have r1 e power I theta 1, then times r2 e power I theta 2, not so. Then this one will give you r1 times the r2, then e to the power of I theta 1 plus theta 2. because for indices, when we are multiplying the same base, then we add the powers, not so. So that means this new complex number here, which is a product of these two, is going to have the argument theta 1 plus theta 2. You see that? Its new argument is going to be theta 1 plus theta 2. So that means, and in fact, let me write it here. Argument of z1 and z2 shall be equal to theta 1, and theta 1 is argument of z1, not so. Theta 2 is argument of z2. You see that? So that is that. Now here, they said that this one here is real. So if it is real, that means it is lying on this axis here, on the real axis. Okay, we don't have the imaginary. So that means this angle here, in fact, we shall have something like this z squared, then times the omega. Okay, this angle here is going to be 0 for anything, for any complex number to be on the real axis. Of course, the imaginary axis, the imaginary is 0. Okay, now if the imaginary is 0, that means your angle here has to be 0. So e power 0 then becomes that 1. So in other words, when I get this theta 1 plus the theta 2 here, then it will be equal to 0. You see that? Now, having understood all of this, I can take everything off, and then we say that z2 argument of z squared times the omega then will be equal to the argument of z squared, then plus, not multiplication, so plus the argument of omega. Okay, then I'm saying since z squared times omega is real, okay, then its argument is 0. Okay, on real axis. It is on real axis. You see that? So this simply implies that the argument of z squared, which we got here as negative pi over 3, not so? That one there, negative pi over 3, then we add the argument of omega, which is actually what? This one here, alpha. Then this one should be equal to 0. So that means that our alpha then shall be equal to pi over 3. If you make this one come this side, you see that? Then what else? We are going to go to this one here, the modulus. So the modulus of z squared out of omega, this one they are saying it is equal to 12. This is the same thing as saying the modulus of z squared out of the modulus of omega then shall be equal to what? To 12, not so? Then I can cross multiply. So the argument of z squared, we have it there as a 4. So I will have 4, then divide by the 12, not so? Then is equal to the modulus of omega. And therefore the modulus of omega shall be equal to a third. You see? Now, this simply implies that, in fact, this one will be the value of r. Okay? So r here, when you look at this, it is the modulus of omega, so it is equal to what? A third. So that means omega here, I'm writing it as a w. So omega is going to be equal to a third, then e to the power of negative pi. No, I think it's a positive pi, not so? It's a positive pi over 3. Okay, but they are saying two possible values. Then how can I get the next value? Okay, how can we get the next value? This is the one here. Now, first of all, this one lies in the 60 degrees. 60 degrees is the, that one is in the first quadrant, not so? But tan, remember when we are getting the argument, okay, we say that the argument of omega, okay, is going to be equal to the arctan, okay, of the imaginary, then over the real part. You see that? Now, tan, okay, tan of that angle, this is pi over 3. Tan is positive in the first quadrant and fourth what? Quadrant. You see that? So if I have something like this here, all positive, then sine only, then tan only positive here, and then cosine here. So if I project this on here and also here, and then we have that angle, because this is positive 60, it is in the first quadrant, right? In fact, let me use alpha. Then opposite angles are equal. It will be here, okay, in the third quadrant. But now, when you move like this, this one is anti-clockwise, the angles are positive. So when you come to this one here, it is going to be above pi. You see that? Because we know that this is 0, this will be pi over 2, this will be pi, okay, this is 3 pi over 2. But when we go like this one is negative. I mean, yes, angles are positive here. And then when we go clockwise, the angles are negative. So instead of going like this, such that your angle is beyond 180, you instead go anti-clockwise. You see that? So we are going to go anti-clockwise up to here. You see that? When you go anti-clockwise, the angles are negative. So how do we get then this angle here? That will be the second value for omega. Are we there? So the second value for omega is going to be, now let us get another argument of this omega. First of all, the angle is negative, okay? The angle is negative because you are moving clockwise. But then from here up to here is 180. So I can say pi, then minus this angle here, okay, which is pi over 3. This will be 3 pi minus pi, which is 2 pi over 3. And then it becomes negative 2 pi over 3. That means the second value of this omega shall be, omega is equal to, it's still the same what? It is still the same modulus here. Then e to the power of negative 2 pi out of 3 of I. So these are the two values here. Question: for the positive numbers p and q are such that the natural log of p over q is equal to a, and natural log of q squared p is equal to b. And then they are telling us to express the natural log of p squared q in terms of a and b. Now let us first look at this one here. Natural log of p out of q, this one is equal to a. Using the rules of logarithms, when you see the powers here in a division, that means they had those logarithms subtracted, okay? So I will have natural log of p minus natural log of q, which is equal to what? To a. You see that? I can make one the subject of the formula. Maybe natural log of p is equal to a, then plus the natural log of q. I keep that. Then I can also go to this one here. There is natural log of, in other words, I'm going to solve natural log of p and natural log of q simultaneously. You see that? The natural log of q squared p, this one is the same as saying natural log of course, here we are seeing it is a multiplication of the two. That means this one is coming from addition of the two logarithms, okay, to the same base. Then you can bring this one down here. So that is 2 natural log of q, then plus we have natural log of p, which is equal to what? To b. And so now we can substitute this one in here. Wherever there is natural log of p, I can put this a plus the natural log of q, and this one is equal to b. Now 2 plus 1, that one gives us a 3. So that one will be 3, then natural log of q. Then this one is equal to, take this one this side, so it will be b minus a. So that means natural log of q is equal to b minus a out of 3. I keep this one. What therefore is our natural log of p? Now substitute this one here. So we shall have a, then plus this b minus 3. No, it is minus a, then out of 3. Not so? Then multiply here. That will be 3a, then minus a, that will be 2a. So we have 3a, then plus the b minus a out of 3. That means our natural log of p then is going to be 2a plus b out of what? 3. And that is that. Now I can come to this one and I say this natural log of p power 7 of q, this one is going to be natural log of p power 7, then plus the natural log of q. Then this one can come down here using rules of logarithms. That is 7 natural log of p, then plus the natural log of q. And then this will be 7. Then what is natural log of p? It is 2a, then plus b out of 3. Not so? Then plus natural log of q is b minus a out of what? 3. Then these are fractions which we can simplify. So we have 14a, then plus 7b when I open the brackets here, then plus b minus a. Everything is out of 3 because it is the common denominator here. That means we have 14 minus a, that one gives us 13a. Then here we get 8, not so? So plus 8b, then out of 3. And what did they say in terms of a and b? I think this is therefore our final answer, and that is that. Question 5 is coming from complex numbers still, but this one is from the part of CAIE. Part A, on a sketch of an Anagram diagram, shade the region whose points represent complex numbers z, satisfying the inequalities here. Now, every time you see the modular signs on one side of the inequality or equation, that is a circle. Okay, and what is given here is the radius. Then if you see two modular signs here, then that will be a perpendicular bisector. Remember, a locus is a region of points describing a certain rule. So it can be, the points can lie on a curve, the points can lie on a straight line, okay? Like that. They can even be between two lines. If, for example, we have an angle bisector. Now, this one here is a circle. Let me prove to you that it is a circle. So the first thing you do is actually to create a negative in between these two. So I will say z minus, then I have this 4. Remember, we don't have to change the meaning, okay? So in fact, let me start the question here. We are having z minus, then we have the 4, and then plus 2i. You don't have to change the meaning. I'm just creating a negative. So two complex numbers in here. Then this one is less than or equal to 3. So this is a circle of radius 3. This one is radius 3 and center. The center is 4, 2. It's 4, 2. Or you can say 4 plus 2i. Now, if we know that this is a complex number, so a complex number, when it's a complex number, you're getting a complex number, right? Then modulus of a complex number, we get the real part, okay? So this one can be, I'm just proving that this one is what? Is a circle. So z can be x plus iy, not so? Then minus, I can say this minus 4, then minus the 2i, then less than or equal to 3. And then here we have x minus 4 as the real part. So I separate it from the imaginary part. Then this one will be y, then minus the 2 of i. Not so? So to get the modulus of the complex number, you get the real part, you square it, then plus the imaginary part. You also square it, then under the square root. You see that? In fact, let me remove the less than or equal. Let me just put equals, okay? Just to make the point go home. Then you square both sides. Then you have x minus 4 squared, then plus y minus 2 squared. Then this one is equal to 3 squared. Isn't this the equation of the circle which is studied in pure mathematics 1, where we say x minus a squared, then plus y minus b squared. Then this one is equal to r squared. So this is a circle of center 4, 2. This is the one, because here this is the a, the b, okay? So the center 4, 2, and then the radius is 3, what I wrote here. You see that? So whenever you see a modular sign, the modular signs on one side of the equation or inequality, then you should know that that one is a what? Is a circle. Now, if it is equals, then that means we are looking at all of those points that are on the circumference of the circle, okay? Because all of them are at a fixed distance from the center, which is the radius of that circle. You see that? But then, if it is less than 3, that means we are looking at points inside this circle, okay? Inside this circle. So any point that is inside this circle, its distance here is less than the radius here. So we are looking at inside the circle. That means when we are drawing, this one has to be dotted. The circumference has to be what? Dotted. But then when we say less than or equal, okay, that means we are going to consider all points on the circumference of the circle, that is the or equal, and then the less than also inside the circle. So when we are drawing that circle, it is going to be bold. And then we also look at the points that are inside the circle when it comes to shading. Is that clear? All right. Now, let us also look at this one here. Now, here we are also going to do the same. We are going to create a negative. So z, then minus, because we have 0 plus 0i. Not so? Yeah, because there is nothing here. Then less than, greater than or equal to, then we shall have 10 here, minus, so I need to have something like this, z then minus something, okay? So I can pull out a negative, then the z is going to be a positive, then minus the 10. I don't have to change the meaning. You see that? I don't have to change the meaning, because when you multiply all through by the negative, so z is going to go back to the negative, and then the 10 will be the positive there. Is that clear? Then this one here is going to be the same as, now I can have my minus here, then 10 here plus 0i. You see that? I'm creating a negative just like here, or like what I showed you here before. Now, of course, I can take this one out, okay? I can take that one out when it comes to the modulus. We can the negative becomes a positive. Okay, so this one is the same thing. Now we have this one off like that, so we write it better that way. Okay, so we are not used to a number then minus the z. We are used to z then minus a number or a complex number there. So here we are looking at, because this one is a distance and then a distance, so you are having two centers. You are looking at those points which are equidistant, okay, which are equidistant from these two centers, and that has to be the perpendicular bisector. You see that? But then you follow the inequality sign, okay? You have to lean, just see where it is. It is pointing this other side. That means go this way. As simple as that. So I'm going to show all of that when we are drawing. So I can say this is a perpendicular bisector of the line joining points 0, 0 and then 10, 0. Okay? So let me write that. And you should know that a perpendicular bisector passes through the midpoint of a line segment. Okay? So what will be the midpoint of this one? We shall have 0 plus the 10 over 2. That will be 5. So it will be 5, 0. So it passes through the midpoint. Now let us draw our axes here. Now, to be very systematic and actually perfect, and you find that you draw something very, very good, because this one is going to be a circle. When you just use your fingers, you're not going to get a very good sketch. So you can use your compass. Okay. Now I can pick my things here. This is a ruler here, and then you can even put your ruler here. They said it is a sketch, but you produce something that is looking good. So you put your ruler here. You can also do the markings. And then I put 1, then 2, then, like that. Okay. I do the markings, because now later when I put my compass on this ruler here, okay, and then I draw, it will be passing through those points very well. Okay. So let us put the markings. So we also do the same thing here. Okay. So this is the real axis, and this is the imaginary axis. Okay. Then after that, let us draw our circle. That is 4, 2. The center is 4, 2. So this is the 4, and then the 2 is up here. So we can have something like this. Now we move 3 units this way. So that means this one is going to be a tangent to that circle. Then 3 units this way, even this one will be a tangent to the circle. Then 3 units this way, this one will be a tangent. Then 3 plus the 2, it will be a 5. So that means when we are drawing, it will pass through, it makes this one here, then this one here, and then something like that. Now you see, when you use just your free hand, you draw something ugly which looks like a potato. So avoid that. That's why I recommend using a compass. Okay. So I'm going to put my compass here at this point, and then I draw. I'll come to my compass here. Then you can stretch it on your ruler. Now mine here, I can see the centimeters, but it cannot reach 3. Okay. So I'm just going to put it at 6, and then I diminish it, okay, to the 3 later. So put it at this point, and then after you draw your circle like that. Of course, this is big, the radius is 6, but then I can diminish it. Okay. In fact, before I do that, let me draw my tangents here. The one at 7, so this one here, just to guide me. Then the one at 1, then the one at 5, like I told you before, and then the one at -1 here. So when I am reducing this one, it should be touching those tangents. Okay. So I reduce it and put it there, the center, and try to enlarge a bit. Like that. Of course, for you when you are doing in an exam, you can't do this, but the only thing you can do is when you measure on your ruler, things are okay. Not so? Now, like that, you can see that it is touching here, it is touching here, and also touching there. Okay, so that has to be our circle there. Now, of course, I don't need these lines, so I can take them off just like that. So that is my circle. Then we have to draw a perpendicular bisector between these two centers, 10 and 0. That one is far away, so it is this side. I'm going to elongate this one here. I had drawn a smaller one, so I'll elongate this one just like that. Now, also plotting these centers carries a mark. So 0, 0 is here, then 10, 0 is here. The perpendicular bisector has to pass through the midpoint 5, 0. So 5, 0 is here. Then I'll get my ruler and then I draw through the 5. Okay. So mine here, I'm seeing some degrees, 200. It has to be 270 there. Then you get this one here. You make it pass through that 5. And this line here has to be bold. Why? Because we are seeing what? The greater than or equal. If it were just greater than or less than, then the line would be dotted, because any points that are on that line are not considered in that case. So here they are considered. Now, we have 0, 0. Okay, 0, 0, the point is here. Then 10, 0. Okay, 10, 0 is this side. So we have these points that are on this side and also points that are on this side. So any point that is here, okay, it is nearer to this point, but far away from this point. In other words, its distance, this one here, is bigger than its distance from this point. And that's what this one says, that the points, the distance of a point from this 0, 0 must be greater or equal to this way. But in other words, just like I said at first, just look at the sign here. Where does it point? It points to this point 10, 0. Okay, so that means you are considering this part that is nearer to that. Is that clear? But then when we are shading, we have to be inside the circle. So this is inside the circle but nearer to this other point. So that means this is the region that we are going to shade. Okay, and then we are done. So let me shade it properly like that. But then I have to label this one. It is the real of z, which is equal to 5. Okay, that line we have drawn here, which is the perpendicular bisector of the two centers. Then part B, find the greatest value of the argument of z for the points in the region. So I have to begin from here. Then I can draw lines to all of these points in here. Now the greatest argument, of course, we are looking at that angle a complex number makes with the positive real axis. Of course, the smallest is going to be when this one you connect it to this lowest point where they meet. And then the greatest angle is when you look at this one here, when you connect also to this point here. You see that? So what I'm going to do is to connect this one to this, but in order not to interfere with our diagram, then we make it what? Dotted. Okay, then our mandate is to find this angle here. So how do we find that angle? We need to know the point of intersection here, not so? So when we get the point of intersection there, then we can be in position to get our answer. So there are many ways, but the first one maybe we can use is get the equation of this circle, then you solve it simultaneously with the equation of this line. Okay, So what will be the equation of the circle? X minus the center, 4 squared, then plus y minus the y coordinate is of course 2, then squared, then this one is equal to 3 squared. Okay, and we saw that before. Then we also have x is equal to 5. Since I've used x and y instead of the real and imaginary, then this vertical one I will use x is equal to what? To 5. Okay, now substituting in here, we shall have 5 minus 4. Where there is x, I'm putting 5, not so? Then plus y minus 2 squared, this one is equal to 9. So we have here y minus 2 squared, then shall be equal to, this one will give us a 1. When it comes this side, it becomes an 8, not so? So 9 minus 1, that is 8. Then we take the square root. So when we take the square root, that will be y minus 2 will be equal to plus or minus 2 root 3. No, 2 root 2, because that will be 4 times 2, then the square root, then you get root of 4 is a 2, and then root of 2 is root 2. So that is that. Then next, that means our y can be equal to 2, then plus or minus 2 root of 2. Of course, we shall take the one for the plus. The one for the minus is the one here. 2 then plus 2 root 2 will give you this value that is there. Now let's take that. So that means tan of theta is going to be equal to the opposite. In fact, to be so systematic and such that you understand everything very well, let me put this one here, the triangle. Okay, our triangle here, this is the angle, then this whole distance here, from here to here is that, because if you get this value, so that is the value of y above the x-axis, not so? So we are having 2, then plus 2 root of 2, and then this one here is 5 units, not so? 5 units. So using SOHCAHTOA, then tan theta is equal to the opposite, which is 2 plus 2 root of 2, then divide by the adjacent, which is 5. So meaning theta shall be equal to the arctan of everything that is here. So I'll just put this one here, and then we put this in the calculator. You can put it in radians or in degrees, so you do what you want. My calculator here is in degrees, so we shall say shift, then tan, and then we have 2 plus 2 root of 2, and then down here we have a 5. So that will be to 1 decimal place 44.0, not so? 44.0 degrees, that is to 1 decimal place. Or if I'm putting it in radians, what do we get? So the calculator is in degrees. What I'll just do is to change it to radians. Shift, then mod, rad is 4, then I press equals again. So that is 0.768. 0.768. Okay, this is in radians, and it has to be to 3 significant what? Figures. So whichever you want is that you write. Okay, but do not write these two answers in the exam. You just say either you put it in degrees or in what? In radians. Question 6, the equation of a curve is this one here. Part A show that dy dx is this. So this is implicit differentiation. Y here is not expressed explicitly in terms of x. So this is implicit. And x and y are all variables. Okay. So what we have to do, we differentiate everywhere. Okay. You will have d dx, then you differentiate 2y squared, then plus 3. Now here, this is a product of the two, so I'm going to use product rule, not so? So I can leave 3x constant, okay? Then I differentiate y. Then I add, now I can leave y constant, you can even write 3y. Then you differentiate what? X. You see that? Then next, you also differentiate with respect to x, this x that is here, and then also on the right side, it's the same thing that you do, x squared here. Now, here, when we are differentiating a function in y with respect to x, okay, we first differentiate that function with respect to y. You see that? With respect to y, then we multiply by dy dx. Why are we doing so? We are doing so because this one can cancel with this, and then you remain with the derivative of this function with respect to y. Remember, this one is not like saying you are differentiating a constant. Y is a variable. It's a function. You see that? So we use CAIE rule. You see that? So that means when I differentiate this with respect to y, I'll get 4y. So I'll write 4y. Then I'll multiply by dy dx. The same thing we have done here. Okay? Then we proceed. When you differentiate, of course, y with respect to x, you get a 1. So you get 3x, then times 1, but then times dy dx. Then here, when you differentiate x with respect to x, of course, you will get a 1. Okay? Then plus, of course, even here a 1. And then this way we get 2x. Okay? Even here, by the way, after differentiating this, we also multiply by dx to eliminate this, but still you have the derivative of this with respect to x, but that one we don't put. It's always silent. You see that? Now get the terms that have gotten dy dx. You put it together. So we have the 4y here. Then we also have the 3x here. Like that. So I factorize out dy dx. Then the rest of the terms that do not have the dy, I take them to this other side. So this is 3y. When it crosses, it's a minus. And then 1, when it also crosses, it becomes a minus. So that simply implies that our dy dx is going to be equal to 2x minus the 3y minus 1. Then we divide by this one here, which is 4y, then plus the 3x. And this is exactly what they have told us to show here. Then part B, hence show that the curve does not have a tangent that is parallel to x-axis. Now, you need to know that if, let's say I have this sketch here, I'm going to sketch such that you understand this better. Now, I have this one as my x-axis, this one as my y-axis. Then there is that line which is parallel to x-axis. Okay, let me just duplicate this line here, which is y is equal to something. Okay, now maybe I have this as the curve. Okay, this is the curve, whichever way the curve looks like, but it is a tangent to this line. Okay, it's a tangent to this line. It is touching it at only one point. Now, this point here, this line here has gotten coordinates. Let's say this is x1, but we have a y coordinate. Even here, we have x2, and then the same y coordinate, because y is equal to something. You get it? So all the y coordinates on this line are equal to, if let's say this one is a 1, so all of them will be 1. It's only x coordinates which will be changing. So if we are finding the gradient here, okay, the gradient, you know that you take the change in y over the change in x. So the change in y will be y minus y, not so, out of the change in x, which is x2 minus x1. But do you see that this one becomes a 0? This one here is a 0. So that means for a tangent that is parallel to x-axis, then its tangent, its gradient is a 0. So let me write that. The next time they can also ask you about the tangent that is parallel to y-axis. So the one that is parallel to y-axis, this is our y. Then we'll have x here. All x coordinates are the same, but then y coordinates are changing. You see that? That means when you're finding the gradient of this one, it is going to be changing y, which is y2 minus y1. Then out of change in x is x minus x. So you are getting the change in y over 0. So that means the denominator is 0. So a line that is parallel to y-axis has its gradient undefined because of this 0. So you get your dy dx, you get the denominator, then you equate it to 0, and then you proceed. Is that clear? Now, let us proceed with what we are having here. Our dy dx, remember, it is 2x minus 3y minus 1 over 4y plus 3x. So this is 2x minus 3y, 2x minus 3y minus 1. Then we divide by the 4y plus 3x. We have to equate this one to 0, like we have seen here. Okay. Then you can cross multiply. Of course, this one is going to go with a 0. Then you can take this one to this side. And then we shall have 2x. This one is equal to 3y plus 1. And maybe to make x the subject, x will therefore be equal to 3y plus 1 out of what? 2. Then from there, we go to our curve. This is the equation of the curve. Then we substitute where there is x, we put 3y plus 1 over 2, and then we solve that equation. But if we fail to solve the equation, then that means the curve doesn't have the tangent that is parallel to x-axis. The curve can have that tangent if you can solve that equation. And in fact, if that tangent is there, then they ask you to find the what? The coordinates. You see that? Of those points through which the tangent passes. Okay, so now let us go to our curve. Remember, our curve is given as 2y squared, then plus 3xy, and then plus x, which is equal to x squared. That means if I substitute where x is, and then I put 3y plus 1 out of 2, then there is this y here. Again, we have 3y plus 1 out of 2. Then this side, we also have 3y plus 1 out of 2 in squared. Let us open the brackets. So we have 2y squared, then plus, this is 3y times 3y, isn't that 9y squared? Then plus 3y, then times 1, that is 3y, then over 2. And then 3y plus 1 over 2. Then here we are going to square what is up and also down. Okay, now square this 3y, you get 9y squared. Then 2 times 3y times 1, that is 6y. Then square the 1, you will get a 1. Then out of square the 2, you get a 4. Now, we can multiply all through by 4, not so. All through by 4. So when we multiply all through by the 4, why am I multiplying all through by the 4? Because it is the LCM of these 2, 1, and 4. Also, so multiply here by 4, you get 8y squared. Then here this 2 would multiply. This 2 goes into the 4 2 times, not so. Then 2 times this one, that will be 18y squared. Then again 2 times this one, you get 9y. Okay. No, 2 times 3, then you get 6y, not so. Then plus, we are putting a 4 here again, you are getting a 2. So that 2, then multiply by 3y plus 1, so you get 6y, then plus 2. Then this other side, of course, when I multiply by 4, the 4 disappears. So that means I'll have 9y squared plus 6y, then plus 1. Okay? Then from there, we can simplify. Of course, this one can disappear with this. Not so? Then this one will be 26y squared, then minus the 9 squared. Okay, let me write 26y squared, then plus 6y plus the 2, then bring everything this side. You have minus 9y squared minus 1, which is equal to 0, because I want to get a quadratic in y. So 26 minus 9, I think that one gives us 20, no, it gives us 17, yes, 17y squared, then plus 6y, and then plus 1, this one is equal to 0. Now, since they are saying that the curve does not have a tangent, that is what we are supposed to show. That means we can't solve this quadratic equation. But to get non-real values, when you solve a quadratic equation, that means the b squared minus 4ac has to be less than what? 0. Remember, we solve using this minus b plus or minus to the root of b squared minus 4ac out of 2a. If this one is greater than 0, then you can get the real values, the two distinct values, okay? Because you use the plus and then the minus. If it is equal to 0, that means this whole thing is going to go, and then you get a repeated root, which will be minus b over what? 2a. And then if we get this one as less than 0, then you are not getting the square root of the negative. You are not getting real values, but instead complex what? Complex values or complex roots. So what do we then do here? We just need to show them that our b squared is a negative. So I mean b squared minus 4ac is a negative. So b squared minus 4ac is going to be or you substitute in the what? Let us show them that we are substituting in the equation. So y is equal to minus b, then plus or minus to the root of b squared, then minus 4ac, then out of 2a. Okay, so this will be negative 6, then plus or minus. This will be 36 minus 68. 36 minus 68, you get negative 32. So we have the square root of negative 32, which is out of the 34. So this one here doesn't give us what? The real roots. Okay, so we shall say no real roots or no real values. Okay, and then we conclude that therefore the curve has no tangent parallel to x-axis. Well, in fact, I can just say no tangent parallel to x-axis. No tangent parallel to x-axis. And that is that.